Exponential functions, how to use a formula, and all the basics. Usually an exponential function can be represented in three different ways. One is from the equation, another is from a graph, and the last is from a table. In textbooks, this is normally the formula you see. The key thing that makes these exponential is that the x is in the exponent. Usually they use the variables a and b. Main thing to notice here is that the b is the one that has the x as the exponent, where the a is just multiplying on the outside. The number that's in the spot for a is usually the y-intercept of your graph, or the starting point of a word problem. And again, the key thing that makes a different is it does not have the exponent. The b, on the other hand, is the one that does have the exponent, and it's usually called your growth or decay factor. Just like in nature, growth is when our equation will be going up, where decay is when our situation will be going down. Before we go over an example of how to use the formula, let's take a look at a graph. The graph of an exponential function is usually easy to recognize because it's either a ramp that's going up, which is growth, or a ramp that's going down, which is decay. Let's use this growth graph as our example. Notice our graph has a y-intercept of 3, and as our x's increase by 1 each time, our y's are multiplying by 2 each time. So if we were to try to make an equation with this, the a value, which is our y-intercept, would be that 3. Again, the a is just multiplying on the outside of the equation, it does not get the exponent. Our b, the growth and decay factor, is the value that we're multiplying by each time. So in this case, because we multiply by 2, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. That would mean our b value would be 2 because we're doubling. Don't forget the final step on these, put that x in the exponent to show that it's an exponential equation. So this right here would be how to use the formula in order to turn that graph into an equation. So now let's turn it into a table. So here we have a blank xy table, and we're going to fill it in with the values from our graph over here. Our first point is this y-intercept of 3, which has an x value of 0. So here's how you'd write that point in the table. Using that same idea for our next point, our x value is 1, and our y value is 6. And for our next one, our x is 2, and our y is 12. And for this point over here, our x is 3, and our y is 24. Notice we still have a blank spot for our fourth value of x, but it doesn't show up on this graph. If we were to move one more x over from our 3 to our 4, our graph would continue upward, and we would just need to multiply the previous point by 2. So every time our x increases by 1, our y multiplies by 2, and 24 times 2 would give us 48. So technically that point would be somewhere way up there. So when you're looking at a table, the biggest thing to recognize for exponential functions is that as your x increases by the same amount, your y's will multiply or divide by the same amount each time. So that's a quick gist on how to recognize an exponential functions in each of these forms, and just know that you may be asked to switch between each. They may give you an equation and want you to make a graph, give you a graph and make a table, make an equation, and so on. So let's just say they gave us this table as an example, and they wanted us to finish filling it out and to write an equation for it. First off, don't let the negative point confuse you. Just see what your x's are changing by. From -1 to 0 is adding 1, and from 0 to 1 is also adding 1. From 10 to 30 is multiplying by 3, and from 30 to 90 is also multiplying by 3. If you can't recognize what they're multiplying or dividing by, put your bigger number in the calculator and divide it by the number behind it. That will tell you what it's multiplying by. So in order to fill in our missing piece, we're just going to continue the train. Here we were adding by 1, so if we continue to add by 1, our x will come to 2. And for our y's, we were multiplying by 3, so if we multiply 90 by 3, we get 270. So now how do we make this into an equation? Remember, your formula is a times b to the x, where the number on the outside is your y-intercept. And your y-intercept will always be the value wherever your x is 0. So in this case, when our x is 0, the y is 30, and so our a is 30. Remember, your b is the one that gets the exponent, and it's the growth or decay factor, what you're multiplying or dividing by each time. In this case, because we're multiplying by 3, our b to the x would be 3 to the x. And there you go. That's how you turn it into an equation. Thanks for watching. Please like and subscribe for more videos, and share this with anyone who you know is learning about exponential functions. Stick around for the next video where we go over some more challenging examples.